Hi class, Mr. Beals here with our next video. Just wanted to go through one of the problems that we had put on the, actually that we did in the in-class review today. I know you had separate ones for your homework tonight, but I picked this one out of all of the options because I think this one gives us the best opportunity to use a couple different skills in order to solve this type of problem. And again, with complex diagrams, which is what we classify the problems that we're working on today, the key here is just finding your particular angle relationships. And then once you have a particular set of skills, there's a couple that you're going to use more often than others. And so I wanted to review those real quickly and before we actually get into the problem. And that is, we need to be really good at these two skills. And the first one is understanding the triangle sum theorem. And that theorem states that the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. In other words, the sum of all the angles inside a triangle is going to equal 180. So if you have two of the three, you can add those together and then subtract that from 180. Unfortunately, you need at least two of the angles in order to find the third, because you can't just subtract one of them out. You wouldn't know what portion constitutes the other two angles. So again, once you have two of the three, you can just add them together, subtract that from 180 to get the third. The other angle relationship, and it might be a little bit difficult to see, and those are linear pairs. So when we have a straight line and then another line creating an angle, this straight line, basically what this is saying is that the angle created over on this side, which is represented by x, plus the angle on this side created by the other side of that line is represented by y, and x plus y is equal to 180. So in other words, when you have a linear pair, that's the definition when you have two angles that are adjacent to each other that create a straight line, and therefore that straight line is going to be 180 degrees. Very similar to taking a look at the bottom of your protractor, for example. Okay, so if we have those two skills down pat, we'll have pretty good success in these type of problems, because those are going to be the most frequently used skills that we use to solve these kind of problems. The only other part that we need to be good at, of course, is what we've been doing for the last 10 days, and that is to recognize, angle relationships and understand if those relationships result in congruency or supplementary. So with that, let's go ahead with this problem. Again, I picked this one because it gives us a couple different steps. Now, the problem gave us a couple of expressions, and again, when they give us expressions, that means that there's going to be a variable in it. And this says angle 6 equals 9x plus 88. And then angle 4 is going to be, 6x plus 182. So the first thing that I want to do is look at the relationship between the two angles that they defined for us in the problem. In this case, again, I didn't copy down all of the angles that were on the problem, just the ones that we need. And that is, of course, angle 4 and angle 6, and then also angle 9, which is the top angle inside that triangle. So again, I'm looking at this relationship, and without going through all of the angle relationships, I should be able to quickly recognize that those are both same side interior angles. And as we discussed, SSS, same side supplementary. So what that means is that the measure of angle 4 plus the measure of angle 6 is going to equal 180 degrees. Okay? But since I don't have those actual degree measures yet, I'm given expressions. What I need to do is add these two up and then make that equal to 180. So off to the side over here, I'm going to 9x plus 88. That's the expression for angle 6. Plus 6x plus 182 for my measure of angle 4, and that's going to equal 180 degrees. So the next step, of course, would be to combine like terms and then solve for x. So the first step is identifying which terms are alike. And again, as I mentioned back when we went through that lesson, What works well for me is to use some sort of marking or identify which of my like terms. So I'm using a double underline. Of course, you can do circles, you can do clouds, circles, squares, whatever works well for you, so that I can identify which of my terms are alike, so that I'm going to add them together. So I get 9x plus 6x. It's going to give me 15x. I have plus 88 and plus 182. Add those together, I'm going to get 270. And all of that is still equal to 180. So now I'm at the stage where I'm going to use the two-step to solve equations. And the first one, it would be to isolate the variable on one side of the equal sign. And since it's positive on this side, I'd like to just keep it there. So I'm going to have to take the constant, get it to the other side. So I'm going to use the inverse operation. I'm going to subtract 270 from both sides. I now get 15x equals a negative 90. And again, a lot of people, when they were going through this problem in class, said, obviously that's a warning. We have a negative, obviously, when we divide both sides by 15, which is the second of the two steps to solve equations. I now have x equals a negative 6. Many people, as I asked around the class, asked if this was okay, if we're allowed to have a negative value for our x, and many people answered that no, and that's actually incorrect, because what is important is that once we put it into the expression, that the expression results in a positive degree measure. So again, what we're going to do is take the negative 6 and plug it back in for the x's in our expressions, and then do the math and see see what that adds up to. If that was a negative number, then of course we would have a problem. You cannot have negative degree angles. So the other thing I want to mention is, again, in test taking strategies, I want you to take a look at which angles you actually need, and instead of going and plugging in 6 in both expressions, I'm going to take a look and see, do I need both of them? I might not have to do this one at all, because again, my problem is asking for two things: the value of x and the measure of angle 9. So we already have the value of x, so I'm going to go ahead and write that answer here in that answer line. So now all I have left to do is find the measure of angle 9, which is part of this triangle up here. So I don't even have to worry about angle 4 anymore, so I'm not going to even bother putting in the negative 6 into here and finding out what that means, or what that adds up to. I'm just going to simply do this one. So I have 9 times a negative 6. Again, I'm going to substitute my x value back into the original expression, plus 88. So 9 times a negative 6 gives me a negative 54, plus 88. That's going to equal 34. So angle 6 then is 34 degrees. Okay? Now I'm going to take a look at the angle relationships that are created by transversal z and parallel lines x and y. And I can see that these two angles right here are what we call vertical angles, right? Opposite of the intersection, separated by at least one angle. In other words, a non-adjacent angle. Vertical angles, as we know, are congruent, which means that if angle 6 is 34 degrees, then this angle here is also 34 degrees. So in order to solve for angle 9, which is this one up here on top, I just have to add this 90 degrees and that 34 degrees. Let me find some space here. So we got 90 plus 34. That's going to give me 124 degrees. So this angle plus that angle is going to equal 124 degrees. My triangle sum theorem means all three of them add up to 180. So now I could take 180, subtract that 124, and I'm going to get 56. Angle 9 is 56 degrees. And that's it. That's how we solve for any unknown angles. Again, just a quick reminder. First, we need to be good with our triangle sum theorem, the linear pair. theorem that adds up to 100. Both of those add up to 180 degrees. We're going to use those two skills very, very frequently. Then the next big skill that we need to be able to do is identify what the relationship is between the two expressions that we're given. Sometimes we're given another angle, and actually that's in a degree measure, not an expression, so it won't have a variable in it. Nonetheless, the reason that we need to know those relationships is that if they result, as in our problem here, where they're supplementary, which means then we're going to add them together to get to 180 and then solve for x. Or if, for example, instead of angle 4, the expression was for this angle on the other side of the parallel line, which means 6, and this angle, I forget which angle it's identified on the problem, but those two would be congruent. So I would have set these two equations equal to each other before solving for x. But of course, once I solve for x, then I'm going to substitute that back into the angle that I need. So again, once I solve for that variable, I plug it back into the expressions. Now I get the angle measure. Then I continue to look at relationships that I can use for my advantage. These two angles are what we call vertical angles, so they're congruent. Then I'm going to use the triangle sum theorem to add up the two angles that I know, subtract that from 180, and solve for the angle that I don't. And that's pretty much it. Again, I used this problem just because it gave us a couple different skills that we needed to be aware of, and that's pretty much half the battle. So thanks very much. Again, sorry for the length and the lateness of the posting of the video. Hopefully it's still helpful. I'll try to put some more on tomorrow, a little bit earlier in the evening, so to give you a couple different options to study as we prepare for the test on Friday. All right, thanks, and hope you found it helpful. Have a good night.